resistors in series. When there's only one path for current to flow in your circuit, we call it a series circuit because your resistors come in a series. Charge has to be conserved in a closed system, so that means that current has to be conserved. We'll get to this a little bit later in one of the later lessons today. But if there's only one path, you know that the current must be the same the whole way around because there was nowhere for it to go. When you added more batteries, so this was circuits 4 and 5 in your lab, there was more voltage, okay, and the bulbs got brighter. So, you know that voltage is proportional to current. You also actually know this from our equation for power that we learned previously. When you added more bulbs, okay, the bulbs got less bright. So, you guys discovered that resistance is inversely proportional to current. So, I can also write it this way. So now I have two things written as a proportionality to current. When I combine those, I get this proportionality. We'll see this again soon. All right, so resistors in series. If they're in a line just like we did today, their resistance just adds up. We call the sum of the resistors in a circuit, any circuit, their equivalent resistance. So if you add up the net effect of all the resistors in whatever combination, that's the equivalent resistance of the circuit. You can also do this for just a part of a circuit called a branch as well. So, resistors in series, the equivalent resistance just R1 plus R2 plus 3, 4, whatever. All right, here's a practice problem. What is the equivalent resistance of a circuit with a 12 ohm resistor in series with a 6 ohm resistor and a 2 ohm resistor? Well, it says series, and we now have an equation for that. And in that one, we just add up the resistances. So 12 plus 6 plus 2 equals 20, and don't forget your units.